All right, good morning. It's Thursday, May 7th. And this is E-Period Algebra 1. After today, we've got 4 more classes together, so we're coming down to the bitter end, or bittersweet end. Couple of announcements. The test, I don't believe I've put them in blackboard because I'm still waiting on a couple of folks that we've had some technical issues getting the test to me. So hopefully we'll have that all resolved, graded, and in there. I'm going to say by tomorrow morning. It might be later on today, but just in case we run into some more difficulties, I promise I'll have them in by tomorrow morning. One way or another, even if I don't have the ones that I'm still kind of waiting on. Okay, let's see. I'm trying to think any other announcements. I don't think I do. Any questions for me before we get rolling? All right, so here's the plan. As a review on, excuse me, let's see, what was it? On Tuesday, we started chapter 6, and we started systems of equations, and you had a couple of problems to do. A couple of you had written me about the homework. There was no Dropbox for that. I didn't collect it or grade it, okay? So we talked, we use this term systems of equations, and it sounds like some high-tech deal going on, but it really isn't. It's a fancy way of saying we've got two linear equations that we can graph. Part of it is, what is the relationship between those two equations? And there's 3 possible outcomes of them. The lines could intersect, all right, and they've got 1 point in common. That's one outcome. And that's going to be probably 80% of our scenarios. That's one outcome. They could actually be this exact same line that you may not recognize it. We're going to do a couple of examples today that it's actually the exact same line, all right, even though the equations appear very differently. But we can simplify the one maybe equation with the larger coefficients. It will morph into the other equation that maybe has the smaller coefficients. And this 8 taking a nap, or horizontal 8, actually means infinite number of solutions, which means they got an infinite number of points in common along that line. Okay? So that's the second possible scenario. And then the third and final and last possible scenario is that they're parallel lines, which means they don't have any points in common. All right. The answer is no solution. Okay. They've got the exact same slope, but they have different y-intercepts. When we compare these two equations, and we'll see, put the cart before the horse just a little bit. When we solve these, which is what we're going to do today, when we solve these, this one here, if we take the two equations, you're going to get something like maybe like 7 equals 3, meaning the x's and y's cancel out or disappear, all right? Or, which it doesn't, or 4 equals 6, and I'm just making up numbers. It's something that's a false statement, all right? And that's one way you can understand that they're the same line, or what sometimes they refer to or call the lines coincide, okay? Coincide. All right. When you solve or simplify this systems of equation, I'm sorry, let me back up. This 7 equals 3, 4 equals 6 goes over here with the parallel lines, where you're going to get 2 false statements, where 7 doesn't equal 3 or 4 doesn't equal 6. The x and y's will cancel out, and this will make more sense when we do a couple of those. All right. That's parallel lines. All right. And why do these numbers don't match? Because it revolves around what that b or y-intercept, because they have different y-intercepts. They got the exact same slope, and that's why you end up with these 2 numbers that says they equal each other, but they don't. All right, I'm going to change my avoid the confusion. When we solve these with the same line, or the lines coincide, you're going to get a true statement like 4 equals 4, or 6 equals 6, or 0 equals 0. And I know that's kind of like, I don't even know what you're talking about, when we do a couple of these, you see this happen, and I maybe should not have mentioned this until we actually start solving these. So what we did on Tuesday is we solved these visually, all right, or actually graphically, all right. Like these two lines here and these two equations, they're parallel. They don't have any points in common. Whereas this line and this line are intersecting, and they got 1 point in common, all right. And let's see, what else do I want to talk about? Oh, if you look at these two equations, they're for the exact same line, and that is the exact same line. If I divide this guy by 3, I get x plus y equals -1, which when I move things around is the same thing as this equation right there. See, on the surface, they don't look like the exact same line. If I simplify that equation with all the 3's and divide everything by 3, it'll morph or simplify into that, okay? And the reason we did 6-1 first, but I'm not going to spend a ton of time on it, is I wanted you to see visually what the 3 outcomes are. All right. There's one of 3 things that can happen when we talk about what's the relationship between these two equations. They can intersect. All right, which means they've got different slopes. Could have the same y-intercept, particularly if they intersect on the y-intercept. Different slopes, most likely different y-intercepts. And outcome 2 is the coincide of the exact same line, and they got infinite number of points in common, as opposed to just 1 point in common. And third is parallel lines. They never touch, never meet, never cross. Because they're parallel, they'll stay an equal distance apart from each other, and they won't have any points in common. All right, so that's kind of just a review of what we talked about on Tuesday. Any questions before we now, instead of solving or looking at these graphically, we're going to solve and look at these algebraically. Any confusion I can eliminate before we get rolling?
Mr. Gaffney, for
Yeah.
all of them, I just labeled them which line they were. For like A, I think I labeled it intersecting lines, maybe?
Okay. Is that it? You're talking about on the work you submitted?
Yeah.
No problem. I'll take a look at it. I didn't grade that. I'm not going to grade it. There wasn't a Dropbox thing for that. Okay. But I will grade the assignment today, and I'll get you up to speed, so you'll be fine. Okay. Any questions before I come off this screen? And we're going to now, instead of looking at these graphically, we're going to look at these algebraically. Any questions before I move on? All right. Let's see. I got to stop my share. Change the screen. Let's see. I think we want this guy. Okay. So I'll have this loaded on Blackboard a few minutes after class is over. We're going to do, so just if you got some loose leaf paper or any kind of paper there, just kind of hand copy the problems. We're going to do several together collectively. I'm going to have a couple of you, I'm going to have a couple that you're going to do independently. Then I'm going to walk you back through them after you've given a shot at them. And then the rest you'll do for work between next Tuesday. All right. So this is an important section because PSATs, SATs, and ACTs love these problems. So I want you to become pretty darn proficient at solving them. So we're going to solve these.
Sir, what was problem set 2 due on Wednesday?
From 6-1 from Monday?
Yeah.
No, I didn't grade it.
But then I have like 320. I'm confused.
I can't tell you off the top of my head. I'm not going to stop the lesson. If you want to stay after class or check in with officer, take a look.
Okay.
So we're going over number 1, right?
So now we're on. You don't have. I haven't put this in Blackboard yet. So just hand copy the problems. We're going to do.
Somehow I got it.
You've already got it.
Yeah.
Okay. So we're on 6-2, problem set 1, and we're solving these with a methodology called substitution. Okay. This is one of two methods of way of solving these. We're going to do substitution today, and on Monday, or Tuesday, we're going to use a process called elimination. I'll teach you both ways, and you can then pick which one you think you're most proficient in. In the past, I've said solve these using substitution, solve these using elimination. They do the same thing. I don't mind which one you use as long as you've got one of those tools in your tool. Right? Personally speaking, I like elimination better. Because it always works. Substitution sometimes not the best. It doesn't always work. All right. So we've got two examples here. I'm not going to walk through those examples. Hopefully you've got a printer at home or you can print this assignment out. I'm not going to walk through them because they do somewhat of an elongated version of solving them. So I'm going to give you a shorter version of solving them. If you start working on these, say later today or tomorrow over the weekend, and you run into a mental block on how to do these, go to Khan Academy and just type in the search bar, solving systems of equations with substitution. Make sure you put substitution because they could show you elimination or a third method. All right. If you're not a fan of Khan Academy, I like Patrick JMT. Patrick JMT. He has several videos there too you can use. Okay, are we ready? So with your pen there or with your paper and whatever, we're going to solve this. All right. Remember I said in the preview or leading up to today's lesson, and also we talked about briefly on Tuesday, is we got three possible outcomes of what the relationship is between this quote unquote system of equations is. It's two equations. All right. They can intersect, 1 point in common. They can parallel, common, or they can be the exact same line. Coincide is a term that's sometimes used, means infinite points in common. Probably 80% of problems that you're going to be given, particularly on standardized tests, are going to be they intersect with 1 point in common. And they've got one ordered pair that solves both of those equations. Okay. So today's method is substitution. Tuesday's method is elimination. So we're going to actually do that. We're going to substitute something for something. So we're going to do exactly what it says. All right. So this is how we do this. All right. How many variables can I solve for at one point in time? How many variables can I solve for simultaneously? Uno, right? One. All right. I only can solve for one variable. I can't solve for two simultaneously. Okay. So let's look at this. All right. So in this equation, let's look at this. Is that in slope-intercept format? Yay, nay?
Yes, but there's no y
Yes.
intercept.
What's it missing?
Y intercept.
Wait, before I say that. What's the slope of that line?
4 over 1.
What's the y-intercept of that line?
0.
0, because there's nothing there. So we know it goes through the origin and it has a slope of 4. All right, so that's good analysis here. All right, so I know y, it says y equals 4x. So here's what I'm going to substitute. I'm going to substitute that 4x for y in the other equation. And to solve these, of course, I have to use both equations. So why don't I do this? So I've got 3x minus, okay, here comes the substitution part. Since I know y equals 4x, I am going to, quote unquote, substitute that 4x for the y. Equals 1. What we just did? All I did is I substituted that 4x for the y because in that first equation I've got y. You're saying that 4x, that y equals 4x. All right, so now I've got that, what I wanted, I've got one variable solved for. So 3x minus 4x, and please, 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 you guys that are subtracting stuff, these guys are on the both same side of the equation. So I don't have to like add 4x. I'm subtracting 4x. I'm staying on the same side of the equation.
Combining like terms.
Minus 4x equals negative x, right? So just like 3 minus 4 equals negative 1. So I get negative x equals 1, right? Good so far? Okay, so what's x equal? X equals what?
X equals -1.
-1. All right. So now I've got one half of my ordered pair. I know it's -1 and something. All right. So since I know what x equals, I can take either one of these two equations up here, either one, it does not matter, and I can substitute -1 for x and solve for y. So I'm going to substitute once again. And since that top equation is a lot simpler, stuff to navigate through, I can go y equals 4 times what? -1. Bada bing, bada boom. And so y equals what?
Battery operated doesn't have enough power.
So y equals -4, right?
Mm-hmm.
So these two lines intersect, and they intersect at -1, -4. That makes sense?
Yes, sir.
So let's just let's just do something here just to kind of reinforce how this works. So if I substitute -4 for y, and I substitute -1 for 4, I get -4 equals -4, right? -4, which is what I want. So that makes it a true statement, all right? Just like if I substituted -1 for x here, and I get substitute -4 for y, I get -3 plus 4 equals 1. That's a true statement. Make sense? Make sense?
Yes, sir.
All right, number 2 is very similar to number 1. I'm going to give you, number 2 is very, 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 very similar to number 1. So why don't you try that? I'm going to give you like 90 seconds, and then I will post how to solve that on the screen. Take 90 seconds, do it just like we did number 1. All right, do it just like we did number 1. Okay, you ready? Hopefully you weren't watching your screen, all right? So all I did is I substituted 2y for that x, because in that first equation, we say x equals 2y, all right? So we end up with the equation y equals 2y. I should minus 2. Minus 2, yeah. Right, it's messy.
Mr. Gaffney.
Hold on 1 second. And then I subtracted 2y from both sides of the equation. We get -y equals -2. And we're not solving for negative y, we're solving for positive y. So we get y equals 2. Mr. Martin, go with your question.
I have problem set 6-1. Wait, we're on 6-1, right?
Nope, we're on 6-2.
Oh, okay. So that did.
Number 1, which you should, I don't think, I have not posted it in Blackboard. That's why I just wanted to hand copy these problems, and I'll post it immediately after class.
You want a cheesesteak bowl or chicken melt bowl or what?
All right. So we got y equals 2. So now we got to solve for, so we know half our ordered pair is x is something and y equals 2. Okay. Now I'm just going to, now I got to solve for x, and I can substitute, that 2 for the y in either one of those two equations. It does not matter. So now I'm going to go x equals, I'm going to use the first one just because the math is simpler in my eyes, but if you want to use the second equation, that's fine. So we get x equals 2 times 2, right? So x equals 4. Very good. Does that make sense? And did you get that? X equals 4. So 4 and 2 is our ordered pair. I won't plug the numbers back into either one of those two equations. You can do that if you'd like to kind of test the system, but you will get, well, look at it. Let's just do it real quick. If I plug 4 into x, I get 4 on the left side of the equation. If I plug 2 in for y, I get 2 times 2, which is 4. So I get 4 equals 4. And a similar scenario would occur in that second equation there. You get whatever's on the left would equal whatever's on the right. Okay. Are we good? Are we good?
Yes, sir.
I want to move on if we got any confusion. Any confusion, anything I can clear up before we're going to change things up on you just a little bit.
Do we have to turn this? Mr. Gaffney?
Yes,
Well, I
sir.
forgot what problem set we're doing right now. Is this problem set 2?
This is section 6.2, problem set number 1. Section 6.1 was solving system equations graphically, which is what we did on.
This looks like problem set 2.
I'm sorry?
This looks like problem set 2.
It should be 1. Let me see if
I promise you this got to be 2.
No, it says at the top of the Word document.
it says 2 on the Word document.
Yeah, at the very top of the screen.
Uh,
Or no,
why
it
does it say
says,
it's problem-
PS number 1, 6-2. So
Are you looking off a Blackboard, or are you just looking off the screen?
I'm
The
looking
one
on
that
your
you
screen.
sent me, the one that you sent me to send back to you, I think that's problem set 2. Hold on, let me check.
We're working on 6.2 problem set 1.
There's only
6.2 problem
6
set 1. Let
problems,
me.
right?
Yeah,
Shut up, Graham.
This is 6-2 problem set 1. Okay. I don't think I put it on Blackboard unless I did it yesterday inadvertently, but I will make sure it's on there at the end of class today. All right, give me a second here to clean stuff up, and then let's talk. Let's see. Just hand copy the problems, and we're not going to get too wrapped around the axle on the points, on which number it is, but it should be 6.2 number 1. I'll double check.
Am I tripping?
If they're already there, I'll correct any mistakes. Okay, so here we go. So now, if you look, we got a little bit of a horse of a different color here, all right? We don't have x equals a coefficient or variable. We got x equals a whole bunch of stuff, all right? But anytime I got x equals something or y equals something, I can use that to substitute in the opposing or other equation. So that's exactly what I'm going to do. So this is just a little different from what we just did. Same mechanics, but just a little bit different because now I've got that b, or I got that constant. So what I did is I took this 2y minus 3 equals x and replaced it with this x right there. And then I get 2y plus 4. And you can see something's going on here, right? All right. So now if I solve for the variable y, because now I got one variable, and I subtract 2y from this side to get my y's over on the left side of the equation, you can see something's going to happen. What happens? Anybody?
You know why?
No y. So now I have no variable to solve for because that zeroes out, and I got -3 equals 4. Okay, -3 equals 4. And I talked about that with the graphs. And I said, oops, I may have put the cart before the horse. Right. And -3, last time I checked, doesn't equal 4. So what is the relationship of this system of equations? What's going on there?
No solution.
Okay. Why do you say that, Mr. Martin?
Because there's really no answer because -3
Right.
doesn't equal 4.
Right. There is no solution because I have no variable to solve for, right? Right. So if it's no solution, there's no solution. What's the relationship between those two lines?
Parallel?
Parallel. Whoever said that is exactly right. They are parallel lines. So I'm just, if you look up at the top, I am rewriting this thing, these two equations in slope-intercept form, right? I'm just moving, I'm moving the two y's and I'm moving the two y's and the x's, right? So look what, it's messy, don't it? So if you look up at the top here, all I did is I moved the x over to the right side of the equation. I moved the y's to the left side. And if I then put it in slope-intercept form and divide each side by 2, I get y equals -1/2 x minus 3/2 for the top one. Y equals -1/2 x minus 3/2 for the top one. I'm not going to rewrite it because it's going to get really messy. And I get y equals -1/2 x plus 2 for the bottom one. So there you can see I've got both of these in slope-intercept form. They have the exact same slope. And remember, we talked about this before. Equations and slope-intercept form, they have the exact same slope, but different y-intercepts or parallel lines. They're never going to touch, they're never going to meet, and they're always going to be an equal distance apart. So now we're relating this to some of the stuff we've learned over the last 6 months, maybe? Does that make sense? Questions, confusion? All right. All right, so write problem number 4 down on your paper. Write problem number 4 down. Let's see here. Give me 1 second to clean up my mess. Write it down, and then I'm going to kind of get you started, and then I'm going to let you finish. Okay, you've got it written down? Okay, so we're going to use substitution to solve for these. So I've got to take one of these two equations, doesn't matter which one, take this one or this one, and I got to make x or y equal to something. I got to make x or y, just plain old x, plain old y, no coefficient, equal to something. So to me, this one looks easiest, although we could do the bottom one. It's kind of, can I do this? Can I say x equals 2y minus 1? Is that okay to do that? I change that top equation and rewrite it as x equals 2y minus 1. Is that okay to do?
Sure, why don't you use the type options?
I don't know. Because I like to give you a taste of what some of your all's handwriting looks like. No, I have, to be honest with you, I've never tried it. And this way I could kind of put things where I want it without typing. Okay, but I'll maybe mess with that between now and Tuesday. Are you saying you don't like my handwriting?
It is hard to see sometimes.
All right, I will.
Just in class.
I don't want to practice that in class. All right, but I'll give that a try. Okay, so here we go. So now I've got x equals to something. So I can now substitute, I can substitute 2y minus 1 because we say x equals 2y minus 1 and put it right in there. Okay, so I'm going to let you take over from there and solve for X and Y. You're actually going to be solving for Y first because we've eliminated the X's. All right.
Will you go over these at the end of class?
Are we gonna have to turn these in Blackpod?
Yes, sir.
Okay.
We're going to have a chunk of them already done.
See, sir, that looks so much better than you trying to write it.
Hey, I take offense to that.
Dang.
And you can move it where you want it to.
So you're saying this looks better than my handwriting? No way.
Yes, sir.
To be honest with you, I'd never tried it. Okay, since Mr. Seeley doesn't like my handwriting, all right. So I took this 2y minus 1 that we said x equals 2 up here and replaced it for that x. So that's what we did here, all right? And the next step, all I did is combine like terms. Now remember, you guys that like to do the opposite, thinking you're moving it to the other side of the equation, please do not do so. Do what it's telling you to do. It's saying -1 plus 4. -1 plus 4 equals 3, right? We're not moving it to the other side of the equation, so we don't have to do the opposite, all right? And then the only thing I did here is I subtracted 2y from both sides, all right? I subtracted 2y from both sides. All right, so we ended up with y equals 3. Boom, we got half the ordered pair done. All right, and so then I took that y equals 3, and since we know y equals 3, I substituted for this y up here in the original equation, since I know what y now equals. So -2 times 3 is a -6, all right? And then I just added 6 to both sides. So our solution for this system of equations is 5. Be careful, it's an ordered pair. X equals 5, so that comes first. That's why I call it ordered pair, because the order is important, and 3. Make sense? Questions, comments, concerns, complaints? Kudos? Are we good? All right. Before we look at number 5, see anything going on? You can maybe save yourself some heartaches and headaches. You don't have to. You'll find out eventually. But anything
There's a,
out at
there's
you?
a 2x.
Okay. Anything else? How about thinking in terms of, remember the
Oh, you can
GCFs or
divide.
LCDs?
Can you divide all that by 2?
Yeah. If we divide this whole thing by 2, if we divide this guy by 2, oops. All right, not 22. we end up with 2x divided by 2 is x. Negative 8y divided by 2 is a negative 4y. And 2 divided by 1 is 1. Oops. 2 there. So what do we have? We got, come on, bugger, cooperate. We got the exact same equation. Bada bing, bada boom. So what is my answer? And if you solve it this way, that's fine. All right. We didn't really use substitution. We used a little knowledge and intuition. All right. So what is my answer for number 5? Anybody? Think. If I've got
The same line.
exact same lines, so what's my answer? Because we're solving solutions for that system equation.
Infinite.
What means
Infinity.
infinity, which means I could put any ordered pair into both or either of these equations and it would work. All right. It's the exact same line. Infinite number of solutions, zillions. Okay. Questions on that one? Now, do you want me to go ahead? You could, let's do something here.
Sorry.
Give me a second here. I'm gonna pick your brain. All right. So let's say we didn't recognize that. All right. So let's look at something here. So I can then rewrite this as x equals 4y plus 1. Oops. Why is it doing that? Plus 1. All right. So now let's substitute 4y plus 1 for x. So I can go, I'm going to go down here. I can go 2 times 4y plus 1 minus 8y. Mr. Steely, you and happier than a pig in slop equals 2. All right. So now, if I distribute that 2, I get, what do I get? I get 8y plus 1 minus 8y equals 2, right? Now I'm going to combine like terms. So 8y minus 8y equals, there's something wrong here. Oops, this, nobody caught me.
Plus 2.
Yeah, there's an error there. All right, this should be a 2. All right, I knew that. I thought something was haywire. So now I'm going to combine like terms. So 8y minus 8y cancels out. So I end up with 2 equals 2. And remember, we said if it's the exact same line or they coincide, infinite solutions, you're going to get a true statement like 2 equals 2, right? And if they're parallel lines, you're going to get something like 4 equals 7 or 8 equals 11, all right? But what I want to see for this answer is the lazy 8, all right? It looks like Mr. Hunter sometimes in class, he checks in on his class and he's laying in bed, all right? It's like an 8 taking a nap, laying down, resting. It's an infinite number of solutions. All right, Mr. Hunter? Mr. Hunter, did you drop off the planet? No, he's still there. All right. Questions? Questions? Okay, I think I've demonstrated enough to you. If you want to, I'm going to scroll the screen up here just a little bit. Let me do a couple things. Yes. So we've done all the way through 5. So you got 6, 7, 8, 9, 10, 11, 12. So you got about what? 7 problems? 7 problems. Not a monumental task. All right. 7 problems to work on between now and Tuesday. Okay. I think we've done enough that you kind of got a feel for it. if you want to copy these problems down, I'll leave the screen up and I'll actually, no. I'll scroll down to the last three here in a minute. So all you got to copy is 6, 7, 8, 9, and or however, if you've got a printer, just want to wait, I will have this on Blackboard by 10:30 at the latest. Okay. Let's see here. Let me, so any questions on what we did today? Substitution. We're doing exactly what it's telling you to do. We're substituting x equals something for x in the other equation, or y equals something for this in the second equation. It doesn't matter which one, whatever, you kind of just played the hand you've been dealt, all right? On Tuesday, we're going to do elimination, which personally I like a little better, because sometimes substitution doesn't work real well. And I'll explain that more on Tuesday. I want you to do these last 6 problems, all right? 7 problems, and I'll have it on Blackboard here in a little bit. Mr. Gilmartin, you're going to give me page 1 of the test. Mr. Hughes, you said you've already submitted something other than a video for the test.
Yes, sir.
Mr. Seeley, do I need to say anything more?
Yes, sir.
The gravity of the situation, all right? I've got office hours today at 2 to 2:30 and tomorrow from 9 to 10. If anybody wants to check in and pick up an extra 10 points and or get any individual help on this or what we did on Tuesday. Mr. Velasquez, we had that discussion on Tuesday, reference some technical difficulties on your test. Do you need another copy of the test, or do you want to go back and look at what you did and resubmit? This is a test. The test, has a significant higher point value than our classwork homework grades, our rep grades, and our quiz grades. So I don't want anybody to be unduly harmed on the test.
So we're to finish the last 4 problems by tonight?
Actually, there's 7 problems. Here's the
Last 7 problems.
here's the last 3. I didn't want to scroll it up. No, you don't need to do it by tonight because I won't see you guys again till Tuesday unless you check in on office hours. So just have them. Let's see here. Let's have them done by Monday night. Monday night, so I can look at them Monday night, and then we can repair any damages on Tuesday morning.
Okay.
Fair enough?
So there's 15. How many?
Well, we've done all the way through 5, so you just have to do 6 through 12. And I'll have them loaded on Blackboard here by 10:30. If you don't want to hand copy them right now. If you want more practice than that, I've got another problem set with more of the same. Okay. All right. So I think I've done announcements. Again, just substitute. Work slowly and methodically. Focus and concentrate on what you're doing so you minimize careless errors. You're going to substitute something for something. All right. Don't get hung up. Do you want to look at number 7? Don't get hung up on A's and B's versus X and Y's. Also, anything you see on this particular equation, as far as GCFs, LCDs?
Divisible by 2.
Everything's divisible by 2. So let's talk about that. Let's do this. So if I take this equation and divide by 2, all right, I end up with B equals 3A minus 7. Oop, I can't type any better than I can write. All right. Now, how's that relate to this guy right here? Oh, can I now operate off of this equation versus this equation? Yes, I can. Because I can do anything I want. That's an equality property. I can do anything I want to an equation as long as I do it to both sides equally and identically. All right. So if I rewrite this, and I put negative 3a over here, if I subtract negative 3a from both sides, I now end up with negative 3a plus b equals negative 7. All right. How did I do that? Right? Oh, I don't want that. Negative 3a, and this is where the minus should be. All right, so I got negative 3a equals negative b minus 7, right? Let me see where I was going to go with that. Now, if I add b to both sides, now I've got negative 3a plus b equals negative 7, right? Now, if I multiply this whole equation by negative 1, I end up with 3a minus b equals 7, right? So look at this. This guy is the exact same equation as that guy. But if you didn't recognize, it's not that big a deal. Let me erase everything here real quick. If I didn't recognize this, I can solve this by substitution by setting this up. I've got excuse me. I've only got one variable with a coefficient of 1, and that's that negative b. So I could do this, right? I can go negative b equals negative 3a. I know I'm kind of going around in circles here, plus 7, right? And then I can go b equals 3a minus 7, right? See what I did? In this first one, come on, work for me. This first equation, all I did is I moved the 3a to the right side, right? And the next one I multiplied times a negative 1. Now I got b equals 3a plus 7. So I can take, or 3a minus 7, I'm sorry. I can take this 3a minus 7 and substitute it for this guy right here, right? So watch what happens. So now I've got 2 times 3a minus 7. Can't find it, but all right. 3a minus 7 equals 6a minus 14. And then you see what's going to happen when I distribute that 2. I get 6a minus 14 equals 6a minus 14, right? So it's the exact same line. I got infinite number of solutions. So I've already done number 7 for you. All right, so we're out of time. Any questions, comments on anything from today? You guys, about the test, particularly you, Mr. Seeley, since you didn't acknowledge one way or another, I'm going to wrap this test thing up today. So do what you need to do. You too, Mr. Vasquez, Mr. Gilmartin, and Mr. Hughes. You say you've already addressed it, but we're going to wrap this thing up today so I can get the blackboard all up to date.
So Gaffney, I need to email you the problem sets because my blackboard wasn't working.
Say that one more time, Mr. Kelly.
I need to email you the problem sets I was due today because my blackboard wasn't working.
There was no Dropbox for this for the 6th one that we did on Tuesday. I didn't collect or grade anything.
Oh, I thought we were to turn them in.
Now for today's problem set, yes, you have to email. If you
Okay, well I'll have to email you that one.
I'll set up a Dropbox, but if you can't use Dropbox, email them.
Yes, sir.
All right.
So you said office hours are always 2:30, right?
Hasn't changed in the last 4 or 5 weeks.
All right, see you, sir.
See
See
you,
ya.
sir.
We'll see you. Everybody have
Mr. Gaffney.
see you on Tuesday. Yes, sir.
So if I stay, if I come back at office hours, can you talk to me about the test?
Yes, sir.
All right.
All
Have
right,
a
we'll
good
see
day.
you then. All right.